Hello friends, welcome to part 7 of this video series. In this video, we will cover the very basics of DNS. The topics covered in here are the doubts which I had when I started my DNS journey. In my next video, I will have an advanced session on DNS and walk you through the configuration in Infoblox. This video is focused on how DNS works on an Infoblox or Linux-based platform. Because in Windows, working of DNS is a bit different, as DNS records for AD integrated zones are synchronized using AD replication between the different domain controllers. So if you are following this video, to configure DNS on an AD environment or a Windows environment, then I don't think so that this is the the right video to watch. But yeah, that if you want to understand the basic DNS concepts, then please go ahead. Okay, so being said that, let's quickly go through the topics that we want to cover today. We'll start off with understanding the difference between a domain, zone, and an Active Directory domain. Then we will see the different types of DNS servers, the authoritative DNS servers and the non-authoritative or caching DNS servers. Then we will understand or find out the difference between the external and the internal DNS servers. And then we'll find the the difference between a primary and the secondary DNS server. And then we will go through the different DNS records. After that, we will go through the different types of DNS zones and its use case, like in a specific scenario, what is the best DNS zone that can be configured so that our requirement can be met. And finally, we'll see how DNS resolution works with an example. So before we get to the difference between a domain and a zone, let's first get familiarized with a few key concepts or terminologies that's commonly used in DNS. So let's start off with the name server or authoritative name server. A name server or an authoritative name server for a zone abc.com is a server in which DNS service is running and the zone abc.com is configured as a primary or as a secondary zone. So now this primary or a secondary zone, what it is, we will be covering it in this video. But for the time being, just understand that that zone, like for example, if we say that a name server for a particular zone abc.com means that it's a server in which DNS is running and we have that zone configured in that particular server. And again, the name server is always used with reference to a zone. That is, a name server for a zone abc.com may not be a name server of xyz.com because xyz.com may not be present in that particular server. I hope that's clear. Okay, so then we will come to the next important concept which we want to understand, and that is the root domain. The root domain is the highest hierarchical level from where the DNS resolution begins. Or in simple words, I can say that it's a zone which has a name, a dot, just a dot. Okay, so now let's see what root servers are. The authoritative name servers of the root domain are called as or are known as root servers. There are 13 root servers across the globe, but even though we say that there are 13 root servers, in reality there are like hundreds and thousands of DNS servers, but they are configured with Anycast configuration. So what Anycast is, I will not be covering in this in this video because that's kind of an advanced topic. But if you are a beginner, for the time being, just understand that there are only 13 root servers. 13 servers in which we have this dot domain or zone present. So the details will be I'll be giving you the details in the next slide. But for the time being, let's continue. So the root servers contains a delegation zone for all the underlying TLDs or top level domains. Again, if you are a beginner, if you don't understand what delegation zone, it's okay. I'll be covering it in this video. But for the time being, just understand that this root servers contain information about the name servers of the top level domain zones. I hope it's clear. So what is this top level domains? So the DNS zones like the .com, the .edu, .gov, .org, all these are the top level domains. So these are DNS zones, which is one step below the root zone. TLDs are mainly classified into two categories: generic TLDs and country specific TLDs. Examples of the popular generic TLDs are .com, .net, .org, .edu, etc. And examples of some country specific TLDs are .ca, .aus, .in, .uk, etc. Okay, so this is what I was saying. The left figure contains a list of root servers, the 13 root servers, along with the IP addresses. Just a note, every single DNS server contains a file called the root hint file, which contains this information. I will not be, I will be talking more about this towards the end of the video. But yeah, this is just a note so that you can understand that every DNS zone has this 13 servers in a file called the root hints file. Okay, on the right, the figure that you see is the hierarchy of the which we already discussed in this one about the root servers, the TLD, and the second level domains. The second level domains are nothing but our domains like google.com, facebook.com, like that. Okay, so now since we have a kind of good understanding what is a root domain and what is a TLD, let's talk about domains. The domain name like google.com or amazon.com or facebook.com is considered as an identity of an enterprise or organization, or it could be even an individual's in an internet space. Once a domain is registered to an enterprise, organization, or to an individual, they can create n number of subdomains. I'll explain what subdomains are in a bit, but let's see if I want to own a domain, what exactly happens in the background. So let's say I want to buy a domain called mydnscompany.com. So basically, I need to register this domain. For that, I will reach out to an internet domain registrar, and in this GoDaddy, BigRock, etc. Some of the famous ones out there. So in the backend, what is happening is that they are creating, or the registrars are creating, a delegation zone in a TLD name server. In our case, since I want to create my DNS company in under .com, so a delegation zone will be created in the com name server, which will point to the name servers of myDNScompany.com zone. So basically my DNS servers. When I say my DNS servers, if this zone is mine, then I'll be hosting or configuring this zone in my some servers, right? So that's why so those servers are those IPs of those servers will be configured into the TLD.com's name server. So again, we haven't looked into what is delegation, but we will be covering that in this video. For the time being, just understand that this name server of com will have information about the name servers of mydnscompany.com. Okay, so once this registration is complete, in order for the DNS resolution to work, a zone mydnscompany.com must be configured in my DNS server. So again, this can be done even before the the registration process starts. But yeah, anyways, if the DNS resolution has to work, then this zone has to be present. So I hope you get an idea between what is the domain and what is a zone. In some ways, I can say that it's almost similar, but it depends on the context in which we speak, because normally we say domain registration, we don't say zone registration, whereas when we create a DNS zone, like in this case mydnscompany.com, I refer it as a zone rather than a domain. Okay, so that's the difference between a zone and a domain. Like I said, it's depends on the context in which you speak, but it's almost same thing. And then there is the AD domain, Active Directory domain. So an Active Directory domain is a collection of objects within a Microsoft Active Directory network. An object can be a single user or a group, or it can even be a computer or a hardware component. Each domain holds a database containing objects identity information. So that's the whole purpose of having an AD, right? Like one user can log into multiple, has the centralized login information into a database, and he can log in to any of the computer. Okay, so that a domain controller can have a DNS service running on it to resolve the computers or network elements to its corresponding IP. So this is different, but yes, from a high level perspective, we can somehow compare it a zone with an AD domain, but it's completely on the Microsoft side of it or Windows side of it. Okay, so now let's get to the next topic, that is the type of DNS servers. So the type of DNS servers are mainly classified into authoritative DNS server and non-authoritative or caching DNS servers. Okay, so let's see what authoritative DNS servers or name servers are. The DNS server which hosts a DNS zone. Let's take the zone which we are using in our previous slides. That is mydnscompany.com. So a DNS server which contains this DNS zone is known as an authoritative name server or an authoritative DNS server for this particular zone. So an authoritative name server is comprised of both primary and secondary name servers. Again, we will cover what is primary and secondary name servers going forward. Then in an authoritative name server, recursion is disabled by default because, okay, first let's explain what is recursion. Recursion refers to a process of having the DNS server itself making queries to other DNS server on behalf of a client who made the original request. It's like let's say if a machine or a client sends a DNS request to, let's say, facebook.com to my DNS server or to a DNS server that's configured in my computer. So if recursion is disabled in there, that DNS query will not even go out of my DNS server. So that's why in a caching, so when we look into the caching DNS server, we'll understand the difference. So a caching DNS server doesn't have any DNS zones defined in that or configured in that. So the sole purpose of a caching DNS server is to forward those queries to its upstream DNS server so that it will be able to fetch the response and give it back to the client. Whereas the sole purpose of an authoritative name server is not to forward those queries to its upstream DNS servers. Instead, its functionality or its purpose is to return the information that it has, or the record information that particular zone has, to other DNS servers requesting for that information. I hope that is clear. So in an authoritative name server, recursion is disabled by default because the purpose of this DNS servers is to return the info of records contained in that zone rather than sending queries to other DNS servers. Whereas in a caching DNS server, recursion is enabled by default, and a caching DNS server by default doesn't contain any authoritative zones. Its purpose is to receive the DNS queries from the client. When I say client, means a laptop or a computer, and then take that DNS query and check if it's in its cache. Just like the name suggests, it's a caching DNS server, so it stores the frequently requested DNS queries in its cache, and if it's not there, it will go out and fetch the response. But for all these things to happen, recursion has to. There is an option. Recursion is it's a setting in a DNS, so that setting has to be enabled for this to happen. Okay, so let's the example of a caching DNS server is a Google DNS server, which I believe most of you might have heard. And again, please note that these servers are maintained by Google. That's why we call it as a Google DNS server. But these are not name servers of google.com. So I hope if you have been following this video closely, then you should be able to understand what a name server is. So yeah, I hope that's self-explanatory. I hope you understood the difference between an authoritative name server and a non-authoritative name server or a caching DNS server, and the purpose of both of them. Okay, so let's move forward. Okay, the next is the difference between an internal and external DNS server. Okay, so let's see what an external authoritative DNS server is. A DNS server which hosts an external domain. Let's take the same example, mydnscompany.com, and which contains mapping between the hostname and the public IP address of the servers. Like it could be a web server, mail server, etc., which can be accessed or which needs to be accessed from internet. The zone mydnscompany.com present in an external authoritative DNS server must be unique in the complete DNS space. So that's since it's just like something like, if you're familiar with public IP and private IP concepts, we can reuse the same private IP address in within an organization because it's something that cannot be routed outside. But the public IP address, every organization receives a very specific subnet of it, and we cannot two organizations cannot use the same public IP address. Similarly, if you are having an external DNS domain, then it cannot it has to be unique. Okay, so I hope all these the DNS servers which contain which host google.com or facebook.com or youtube.com, all those are external authoritative DNS servers. Now let's look what an internal authoritative DNS server is. An internal DNS server, as the name suggests, hosts some internal DNS zones. Let's say in our example, mydnscompany internal.com. And the scope of the DNS resolution is limited within the organization. The DNS records for the zone mydnscompany internal.com configured in the internal authoritative DNS servers has the private IPs, because obviously inside an organization you don't use public IP address, so it will have a host name to a private IP mapping, and it's mainly used to resolve the names of internal servers, printers, workstations, laptops, etc. The zone mydns company internal.com present in the internal authoritative DNS server need not be unique. Again, since the scope is within an organization, two different organizations can have the same internal DNS zone configured in their internal authoritative DNS server. And an internal DNS zone configured in an internal authoritative DNS server does not require any root or TLD zone or top level domain zone to be defined internally. So that's one big difference, compared to an externally hosted domain. Because if for an externally hosted domain, there is this pattern. It has to go to the root, and then it has to come to the TLD, and then it has to come to the second level domain. Whereas in the case of internal domain, in an internal DNS authoritative zone hosted on an internal authoritative DNS server, it is not required. You can directly, clients can directly query the a DNS server which contains that particular internal zone. Okay, so moving forward, now let's look into the difference between a primary and a secondary DNS server. Okay, so the primary DNS server is a name server in which the zone is first, or zone was first created, or the very first server in which we configure a zone, that will be our primary name server for that zone. And this primary DNS server will contain a read-write copy of the zone. That is, any updates to the zone, like creating a record, deleting a record, etc., can be done only from a primary name server only. And also, details of the DNS servers needs to be configured in the primary DNS server in the form of NS records. Okay, so again, this NS record we will be going through it in the in some time. Yeah, but for the time being, let's understand this much, that information about my secondary DNS servers has to be fed into the primary DNS server, so that it will be able to perform, or the secondary will be able to perform a zone transfer, so that it will be able to sync. A zone transfer is a process in which the secondary is able to receive or sync the records from the primary DNS server, so that both will be in sync. But yeah, I will not be covering in depth into zone transfer, because I'll be covering it in the next video. Yeah, because this is like a overview kind of the basics, basic DNS functioning. Okay, so coming back, the secondary DNS server, the DNS zone is configured as secondary in the servers, contains a read-only copy of the zone, and as secondary DNS servers, we can have multiple secondary DNS servers, so that we don't even have to expose our primary DNS server to the outside world. So we can completely, we don't have to expose it. We can keep it as a stealth DNS server, and we can only expose the secondary DNS servers to the outside world for the DNS resolutions. Because if you remember, both primary and secondary DNS servers are authoritative DNS servers. Authoritative DNS servers means both of them are capable of providing information for the DNS queries that it has received. Okay, so the records or the information contained in the primary DNS server is synchronized using zone transfer. Again, I will not be covering in depth in this video, but in the next one I will be. Okay, so now let's quickly look into the what are the commonly used. There are so many DNS records, but yeah, I will just be covering the most commonly used DNS records. And the most important of the DNS record is the SOA record, also known as the Start of Authority record, containing administrative information about the zone. It is a mandatory record for a DNS zone to even work. It contains information like the primary name server of the zone, the serial number. Serial number is a number which gets incremented whenever there is a change in the zone happening, like adding a record, deleting a record. Whenever there is an update to the zone, the serial number keeps incrementing. And then the admin's contact and various timers for zone transfer, like the refresh interval, retry interval. So all these things are key parameters for the zone transfer. So this example shows how an SOA record looks like and what are the information it contains. Okay, so let's move on. Let's get to the NS record. So the NS record is also known as the name server record. It identifies the DNS servers or the authoritative DNS server which are responsible for a zone. When you add additional secondary zones, or when you add additional secondary servers to host additional secondary zones, then NS records needs to be added so that all those secondary name server will be able to receive or synchronize its records with the primary name server using the zone transfer. Okay, then the next record is the A record, and this is the most commonly used record in the in DNS because it's used to translate a name to an IP address. And PTR is just the opposite of it. It's used to translate an IP address to a name. And another most commonly used record is a CNAME record, and that's used to provide an alias name, and it points to an FQDN of an A record. For example, let's say we have given an alias of web1, which is very easy to remember, web1.mydnscompany.com, but the actual A record is a very complicated word, like it has some numbers. It's a web server 001. So rather than remembering this this weird number, this weird name, it's easier to provide an alias and use that. So whenever we use web1.mydnscompany.com, it will internally translate to this one, and this will internally translate to the corresponding IP address. So that's the CNAME record. Okay, so now let's see what are the different DNS zones and what is the use case of each of these DNS zones. So let's start off with a delegation zone. So if you remember, we already discussed about this delegation zone when we were talking about the domain registration. So in this example, I'll use the I'll give you an example so that you can relate with how the registration of a domain is. You can correlate the registration of a domain after understanding how what is a delegation zone is and how it works. A delegation zone is used when you want to delegate the DNS resolution responsibility of a subzone to a different DNS server. For example, the name server of the zone, let's take the domain name which we have been using for this whole video. mydnscompany.com is ns1.mydnscompany.com. Now I need to create one subzone called north.mydnscompany.com to a different DNS server, that is ns1.north.mydnscompany.com. For this, I create a delegation zone called north.mydnscompany.com in ns1.mydnscompany.com, and in my delegation I need to specify, whenever I'm creating a delegation zone, I need to specify the name server of this my delegated zone. So that is ns1.north.mydnscompany.com. Okay, so when I said verbally, it might be confusing, but if you read the statement or this, it's pretty straightforward. Like the same thing happens when we are registering a domain, because let's say .com. So basically, google.com, we can say that it's a subdomain of .com. So if I want, so whenever if let's say when Google registered its name or its domain, so what it have done is the registrar would have added a delegation zone on the name servers of COM name servers, which will point to the name servers of google.com. So again, if you are just listening this orally, then it could be confusing because there are so many DNS servers in here. But if you read the statement, it should be clear. And if you have any questions, you can get back to me. Okay, so I hope that's clear. So let's get to the forward zone. So forward zone, as the name suggests, if you want to forward queries for a data in a particular zone, define that zone as a forward zone and specify one or more name servers which can resolve the queries of that zone. Okay, so let's take an example. If I want to forward all DNS queries of test.com to a specific DNS server 5.5.5.5. So for that, I need to create a forward zone test.com in my local DNS server and then set 5.5.5.5 as a forwarder IP. But actually this forward zone is very easy to configure, but one big disadvantage is that, let's say if this server goes down or if the server's IP changes, then the whole DNS resolution for test.com will fail, because that's what we are defining, and it's not that's not changing dynamically. So if the IP changes of the server changes, somebody has to statically or manually enter the new IP address. But to mitigate such issues, stub zones are being used. So we'll see what a stub zone is. So when you want to resolve DNS queries for a particular zone, let's take the same example, test.com. Define test.com as a stub zone in your local DNS server and specify one or more name servers that can resolve. Well, let's say we are providing only one name server that can resolve, because in the earlier case we have provided only one, right? So here also we'll provide only one, but that should be able to resolve the test.com. And now what happens is your local DNS server will query the authoritative name server of test.com periodically, and it will populate the SOA, NS and their corresponding A records. So basically, in my local DNS zone, I will have a stub zone, and that stub zone will have SOA, NS records and their corresponding A records queried periodically, and it will be populated in there. So this way, even if IP address of a few name server of test.com actually changes, then also since our DNS server is periodically querying the SOA, NS and their corresponding A records, it will always have the updated list of name servers of test.com, to which my local DNS server will be sending queries to. I hope that's clear. That is, the difference between a stub zone and a forward zone is that both will forward those queries, but the difference is that in a forward zone, if something happens to that IP address or the DNS server which we defined, it will fail unless and until we statically change it or manually change that. Whereas in the stub zone, that once we configure a stub zone, our local DNS server will periodically poll the or query the name servers of that particular test.com and will populate the SOANS and the corresponding A records. And this, since our local DNS server has the updated list, whenever a query for test.com comes, this local DNS server will be able to send it to the name servers, which will be able to resolve those queries. So that's the three different DNS zones. So finally, we will see how a DNS resolution works with an example. So given below are the steps which happens when we try to resolve facebook.com by using NSLOOKUP tool in Windows. First step is like the machine or our laptop or a computer checks the etc host file. If there is an entry for facebook.com is found, then it will pick the IP address corresponding to that entry. If it's not found, the DNS query will be sent to our PC's DNS server. Let's call it my DNS. Now, if the DNS server or my DNS, as we call, has a cached A record entry for facebook.com, it will return that IP address or that A record immediately to my computer. But if it doesn't have any cached entries, then the DNS server will send a query. I'm saying it doesn't have any cache entries. That is, it doesn't have any cache entries of com name servers or Facebook's name servers, nothing. It has no cache at all. In that case, the DNS server will send a query to one of those 13 root servers. If you recollect, every DNS server has a root hint file which contains the IP address of the 13 root servers. So it will pick up one root server, and it will send that query to that root server. Now, the root server will not return you that A record for facebook.com, but instead it will return the NS record of the com TLD, because we are requesting for facebook.com. So it will return the NS record for com TLD to our DNS server, since recursion is disabled in root servers. I hope you remember what recursion is. So now the DNS server or my DNS server will query facebook.com to the com name servers. Since again recursion is disabled in the com name servers as well, it will not return any A records for facebook.com, but instead it will return the name servers of facebook.com to my DNS server. And then my DNS server will query the query for facebook.com to the facebook.com's name server. Since those name servers are authoritative, so if you recollect, authoritative name servers are those DNS server. It could either be a primary or a secondary, that's not a problem, but it has a copy of the zone. So that means it can provide a corresponding record, or it can respond to a query. So in this case, it will send a corresponding A record to the DNS server, that is my DNS server. So now my DNS server will send that A record information back to my PC. So this is how DNS resolution works and I have explained each of these steps. Like, again, if you have, when I say orally, then there is a chance that you might get confused, and especially if you are not an expert in DNS. But if you read it step by step, it's very easy and it's very straightforward also. So let's do one thing. Let's quickly recap on the things that we learned today. So first we went and we gone through the difference between the domain, zone, and an AD domain, and then we went through the we understood the different types of DNS server, and then we tried and figure out what the difference between external DNS server and internal DNS server is. Then we also got to see the difference between a primary and a secondary DNS server. Then we also looked into the different types of DNS records, and also different types of DNS zones, and also what are the uses, and what is the when these different zones needs to be used, and for what is the purpose and what is the advantage of that. And finally we saw how a DNS resolution works with an example. Okay, so as I said, this is just a very basics video, and I thought this video will be helpful because there will be a lot of guys who is very new to DNS, and since I had these questions when I just started, so I thought this video is will be helpful to a lot of beginners. So I will be posting a next video, and in that video we will be covering all these things, or we will be covering the advanced topics of DNS and how it is configured in Infoblox. Okay, so I hope you found this video informative, and we will catch up on the next video. Thanks for watching.